Hello, it is Dr. Lou. In case you have not watched the prior videos, I am the lead faculty member who has created the online laboratory classes using kits from Science Interactive. In today's video, I'm going to go over the calculations needed for the stoichiometry of a precipitation reaction lesson, as well as a brief description of the procedure. Today we are going to look at stoichiometry. I'm going to go over calculations so that we can figure out how to predict the amount of product we will get in a chemical reaction based on the amount of reactants used. So today we are looking at a reaction between calcium chloride dihydrate, and it's going to react with sodium carbonate to form solid calcium carbonate and sodium chloride, which will remain dissolved in water. As I have posted as some supplemental information, calcium chloride is the reactant, but unfortunately, in nature, there will always be two water molecules stuck to calcium chloride, making it a hydrate. However, for the actual chemical reaction, we can ignore the water, and I probably should have written water over here on the product side as well. This water is not part of the chemical reaction. So what is reacting is the calcium chloride with the sodium carbonate to give the calcium carbonate and the sodium chloride. And when this reaction is balanced, we want to pay attention that the coefficients for the calcium chloride, sodium carbonate, and calcium carbonate are all 1. We are not going to use the sodium chloride in any of the calculations. So let us suppose I weighed out 3.5 grams of calcium chloride dihydrate, and I wanted to determine how many grams of calcium carbonate we could produce given that starting amount. To my left is a little flow chart. So this flow chart you have probably seen in lecture, which tells us how to convert between grams or weight or mass of product and the weight or mass of reactants. And I should say here is reactant and over here is going to be the products. The weight of reactant and the molecular weight of the product are not the same. Therefore, we cannot have a ratio of weight of reactant to weight of product. The ratio we need to use is this mole to mole ratio based on the moles of reactant and the moles of product we will form. Remember from lecture class that we can calculate the weight of the, or actually the moles, I should say, of the reactant using the molecular weight. We can calculate the weight of product from the moles of product and the molecular weight. There is a data table for everyone to download that has a few more pieces of information than the one you will formally submit, and I think it'll be a little bit easier for you all to complete that data table first. Okay, let me just write down that we are starting with 3.50 grams, and a little bit high. Let me move this down. So we're starting with 3.50 grams of your hydrate. The first step is to determine the number of moles of hydrate. Given in the experiment, we have now right up here at the top the molecular weight for CaCl2 dot 2H2O is equal to 147.01 grams per a mole. So we will use this molecular weight and the starting weight in order to get moles of hydrate. So I'm going to start the calculation by writing 3.50 grams CaCl2 dot 2H2O. I will put it over 1 for convenience. Then I will multiply by 1 mole CaCl2.2H2O divided by 147.01 grams CaCl2.2H2O. So notice that I wrote the molecule as part of the units. So now we can that the grams of CaCl2.H2O cancel. And what are we left with? The moles of the hydrate. So using a calculator, we can figure out, just take 3.50 divided by 147.01, and that's going to give you 0.0299. So we have 0, and let's use the same color, 0.0299 mole of CaCl2.2H2O. Okay. So next, we'll need this in just a minute. So we'll erase. Let's look at the next step of the problem. So the next step asks us to determine the number of moles of the anhydrous reactant. So looking at the balanced chemical equation, it is the moles of anhydrous reactant that will dictate the moles of the product we will produce. So I'm going to paste this. So this is the moles we just calculated of CaCl2.2H2O. So we are going to convert that into moles of CaCl2. Okay, so we're going to start the calculation. by writing 0.0299 mole of CaCl2.2H2O. We can put that over 1. And now we must multiply by a special conversion factor. So if we look at the formula, there is 1 mole of the hydrate and 1 mole of the dehydrated. So I can write on the top the new unit, which is 1 mole CaCl2. On the bottom would be 1 mole of CaCl2.2H2O. Hopefully that makes sense, and we should be able to now see that the mole of CaCl2.2H2O is going to cancel. Therefore, we are essentially multiplying by 1, which will give us an answer of 0.0299 mole of CaCl2. Let's go to the next step. So the next step of the process is to determine the number of moles of product. So we just calculated the moles of CaCl2. Now we need to calculate the moles of calcium carbonate. Notice there is a understood 1 in front of the calcium carbonate and an understood 1 in front of the calcium chloride as well. So we will start the calculation. 0.0299 mole of CaCl2. To remind us, this value is in the numerator. I'll put it over 1. Then I will multiply by 1 mole CaCO3 over 1 mole of CaCl2. The mole of CaCl2 cancel, so we are left with 0.0299 mole of CaCO3. We have one more step remaining. Let's look at the final step. So now we want to determine the number of grams of the product. So a few minutes ago we determined the moles of reactant by using the molecular weight of the reactant. So we will also need the molecular weight now of CaCO3, which is equal to 105.98 grams per a mole. So in order to do this calculation, now we take 0.0299 mole of CaCO3. We can put it over 1. And then we multiply by 105, I should say, 105.98 grams CaCO3 over 1 mole CaCO3. Notice moles of CaCO3 cancel. So we have another calculator problem. The answer is 3.17 grams of calcium carbonate will form in the reaction. So we have another step to take care of. So the next step they're going to ask us to do online is to determine the weight of the other reactant that is going to be necessary. So how are we going to determine the moles and weight of sodium carbonate? So we're going to need the molecular weight of Na2CO3, which is equal to 100.09 grams per a mole. So we're going to use this molecular weight. And what else do we need? We need to realize that in the balanced chemical equation, there is a 1-to-1 ratio. So let us paste what we had before. Okay. So we're going to change this slightly. So we started with 0.0299 mole of calcium chloride. So we need to calculate the moles and the weight of sodium carbonate. So we will start, and let's see. So what I'm going to write is 0.0299 mole of CaCl2 times 1 mole of Na2CO3 divided by 1 mole of CaCl2. Again, we can put the CaCl2 moles over 1. So now this just becomes 0.0299 mole of NaCO3. Make sense? We see that the mole of calcium chloride cancel. So in the final step of the problem, we're going to take, let's see if I can do this. Whoops. 0.0299 mole of NaCO3 divided by 1. And then we're going to multiply by 100.09 grams of Na2CO3 per 1 mole of Na2CO3. CO3. And what, lo and behold, is our answer going to be? It's going to be about 2.99 grams of, let's see, Na2CO3. Hopefully makes sense to everyone. We also see units can cancel appropriately. These calculations are identical to what you are doing on line, except you are starting with approximately 2.5 grams of reactant. Now let me go and show you a little bit about the experimental setup. So you're going to prepare two solutions. One is calcium chloride, dihydrate, and one is sodium carbonate. So for the calcium chloride dihydrate, you want approximately, let's see if I can do this, 2.50 grams. Does not have to be exact. And for this guy, the carbonate, you want to calculate the approximate weight you will need. Okay, so in this picture, I have already dissolved the calcium chloride and the sodium carbonate in water. I believe the experiment says to use about 25 milliliters of water for each. The exact amount of water does not matter, although we do not want to use more water than is going to be necessary. Then, afterwards, it does not matter which one. We're going to take one beaker and pour the contents into the other beaker. So now, let's see if I continue. Let's see, here it is. Okay, so after we have carried out the reaction, we will see what happens to be at the bottom. We have a white precipitate, also looking cloudy. So this precipitant is the calcium carbonate. Another name for calcium carbonate is, so this is calcium carbonate or limestone. The aquifer under the ground in Florida is made up of rock. That rock is limestone. The chemical name for limestone is calcium carbonate. So keep that in mind. You are synthesizing limestone in this reaction. So now we must isolate the calcium carbonate. So you set up a funnel. Inside the funnel is going to be filter paper. Pour the precipitant solution through this funnel and rinse with as much water as necessary so that all of the solid remains in the filter paper and none is left in the beaker. When we are finished, we are going to have the filter paper with the calcium carbonate, and we're going to take a picture and let dry. Then, following the procedures online, you will be able to determine your actual yield to calculate the theoretical yield.